At 1:47 p.m. over the Black Sea, 5 small aircraft were flying so low that radar could barely see them. Within minutes, a chain reaction would unfold near Crimea that military planners across the world are now quietly studying. They were not fighter jets. They were not cruise missiles. They were far cheaper and far slower. Yet what followed forced a hard question about how modern air defense truly works under pressure. This was not just another strike in a long war. It was a live test of reaction speed, coordination, and economic balance in combat. And before the smoke cleared, it exposed something far more important than damaged equipment. What happened next deserves a closer look. The operation began with a simple but calculated decision. Approach from the sea at very low altitude because geometry can sometimes protect you better than armor. According to available reports, a group of UJ-26 Beaver long-range unmanned aircraft moved toward Crimea, just above the surface of the Black Sea, staying close enough to the water that radar systems would struggle to see them until the last possible moment. This kind of flight profile is not dramatic, but it is deliberate. Radar does not see in straight lines forever. Because the Earth curves, ground-based systems can only detect low targets within a limited horizon, and at sea level, that detection range can shrink to less than 20 kilometers, depending on antenna height. For a slow aircraft traveling roughly 150 kilometers per hour, that distance may translate into only minutes of warning. In military terms, minutes can decide everything. Flying low over open water also reduces clutter from terrain, but it creates a different type of shield: predictability. The western coast of Crimea, especially near Eupatoria, offers long stretches of flat shoreline with fewer natural obstacles. That geography matters because it allows attackers to calculate radar blind spots while accepting exposure once they cross the coastline. The choice of directions suggests reconnaissance and prior mapping of defensive layouts. This was not a random line on a map. It was a path likely studied in advance. Crimea has been heavily militarized since 2014, and the western sector supports air operations and surveillance assets that help secure Russian activity across the Black Sea. Approaching from that angle signals intent, not improvisation. The use of long-range UAVs further supports that conclusion, because platforms like the UJ-26 are not designed for short symbolic raids. They are built for distance, endurance, and payload delivery. Open-source estimates suggest that this class of drone can travel several hundred kilometers and carry an explosive load significant enough to damage fixed infrastructure. That means the mission required launch planning, navigation programming, and target confirmation before takeoff. It also means the objective was likely high value, since expending long-range systems for minor disruption would not make operational sense. When a military invests in deep strike tools, it usually aims at assets that shape the battlefield beyond one day of fighting. Eupatoria's importance helps explain the risk. The region has hosted aviation elements and long-range radar coverage that feed into Russia's broader air defense network. Systems deployed there contribute to early warning across parts of southern Ukraine and the Black Sea corridor. Disrupting that network, even temporarily, could affect response timing and situational awareness. In modern conflict, blinding an opponent can be as valuable as destroying hardware. That strategic logic gives context to the approach vector, because it suggests the attackers were not simply testing defenses. They were probing the architecture behind them. Still, low altitude does not equal invisibility. Sea-skimming flight reduces detection range, but once the drones approach land, they rise into radar coverage shaped by coastal elevation and antenna placement. Crimea's western edge includes cliffs and higher ground that extend line of sight. A defensive system positioned on elevated terrain can see farther over water than one located inland. That means the attackers were betting on timing, not total concealment. They were likely aware that detection would come eventually, but they aimed to compress the response window so tightly that defenders would struggle to coordinate. In this kind of contest, seconds matter more than speed, and confusion matters more than power. What makes this opening phase significant is not just the flight profile, but the intent behind it. The attackers accepted that some losses were possible, because any layered defense would respond. Yet by approaching at sea level, they forced the first engagement to occur under pressure. When a defensive network is compressed into a narrow reaction window, It must perform flawlessly across multiple systems. Any hesitation or miscalculation can ripple forward. That is why the geometry of the approach becomes more than a technical detail. It becomes the foundation of the entire event. And before the drones even crossed the shoreline, the first layer of defense had already begun to react. The first serious response came from a Panzer S-1 air defense system, and it showed that Crimea's layered shield was active and alert. Reports indicate that the system detected the incoming UAVs while they were still offshore, which means radar operators were scanning beyond the immediate coastline and tracking low targets over water. The Panzer combines search radar, tracking radar, and missile launchers on one mobile platform, and it is designed to protect larger systems from cruise missiles, aircraft, and unmanned threats. In this case, the system reportedly locked onto the formation at a distance estimated around 15 to 20 kilometers, which would give only a short engagement window against low-altitude objects moving at moderate speed. That short distance compresses time, and in air defense, time equals survival. At least one drone was intercepted before it reached land, which confirms that the defensive layer was not symbolic but functional. The 5.7E6 missile used by the Panzer travels at roughly Mach 3 to Mach 4, meaning it can cover several kilometers in seconds once launched. Guided by radio command and radar tracking, it does not rely on heat signatures, so small engines do not protect a target. When that interceptor struck its target, it demonstrated that the network could respond under pressure. For defenders, this mattered because it prevented a clean penetration and forced the attackers to react in real time. Yet even a confirmed kill did not end the threat, and that is where modern warfare becomes more complex. The remaining UAVs reportedly altered course and began flying in irregular patterns, which suggests pre-programmed evasive protocols or remote operator intervention. Air defense missiles often rely on proportional navigation, a method that calculates where a target will be in the future and then guides the interceptor toward that point. That system works well against aircraft flying steady paths, but it struggles when targets change speed and direction unpredictably. Small drones have low mass and tight turning radius, which means they can shift angle faster than a heavier missile can adjust its fins under high G-force stress. When flight paths become erratic, the math behind interception becomes harder, and even advanced systems can face difficulty if tracking solutions degrade. This phase highlights a basic truth. Interception reshapes the attack instead of ending it. When one drone was destroyed, the remaining units did not retreat. They adapted. That reaction forces defenders to launch additional interceptors, and each launch carries cost and time. Missiles are expensive and limited in number, while drones can be produced more cheaply and deployed in greater volume. This creates a tension between quality and quantity. The Panzer proved capable, yet it was now dealing with maneuvering targets rather than predictable ones. Every new adjustment required rapid calculation and decision-making under pressure. The engagement also illustrates how layered defense depends on seamless coordination. The Panzer is often part of a broader system that includes long-range radar and other missile platforms. When an initial interception occurs offshore, operators must quickly reassess threat direction and determine whether additional units should engage. That coordination must happen within seconds, because slow communication creates gaps. In a high-tempo scenario, even a small delay can allow remaining attackers to slip into a closer engagement zone. Defense in depth works only if each layer hands off responsibility without confusion. For observers in the United States who study integrated air defense networks, this moment is instructive. It shows both strength and vulnerability. The shield detected and destroyed a target, which confirms operational readiness. Yet the survivors changed behavior, and that forced the system into adaptation rather than routine execution. Modern conflict is not a simple exchange of fire. It is a contest between prediction and disruption. When prediction fails, even briefly, attackers gain momentum. By the time the offshore interception ended, the situation had shifted from controlled engagement to compressed reaction. The medium-range shield had scored a hit, but it had not stopped the operation, and once that first barrier was breached, the battle moved closer to land, where older guns and human reflexes would soon take over. Once the medium-range shield had done its part, the fight moved into a far more brutal phase because the remaining UAVs entered the envelope of close-range anti-aircraft fire. After crossing the outer defensive layer, the surviving aircraft reportedly encountered a Zu-23-2 twin 23mm cannon mounted on a military truck, and this system represents a very different philosophy of protection. Unlike missile batteries guided by complex tracking computers, this weapon relies on optical sighting and human reaction, and it compensates for limited precision with raw volume. The Zu-23-2 has a combined firing rate that can reach roughly 2,000 rounds per minute, which means the air in front of it can quickly fill with high explosive shells. In simple terms, it does not try to hit a single moving point. It tries to make the sky dangerous. This stage shows that legacy equipment still has a role when placed in the right position, because proximity reduces the need for long prediction windows. At short distance, even a small target can be damaged if enough projectiles are in the air. Reports suggest that one UAV was destroyed during this barrage, and that outcome fits the weapon's design purpose. The Zu-23-2 was originally developed during the Cold War to defend against low-flying aircraft and helicopters, and while it lacks radar integration, it delivers immediate response once a gunner acquires visual contact. A shell traveling at high velocity can shred light structures, and fiberglass frames do not offer meaningful protection against explosive fragmentation. What makes this moment important is the shift from guided interception to saturation fire. Instead of calculating impact points, the crew aimed to create a curtain of metal that any incoming object would struggle to pass through. This approach does not depend on electronic networks or digital command links, and it does not require coordination with distant radar stations. It depends on eyesight, discipline, and ammunition supply. In conflicts where drones move at around 150 kilometers per hour and fly below treetop level, reaction time is measured in seconds. A gunner who hesitates loses the chance, but one who commits immediately may force a target into evasive movement that disrupts its route. However, heavy fire alone cannot promise complete security because denial space has limits. Ammunition is finite, barrels overheat, and accuracy drops as distance increases. Even at high rates of fire, small unmanned aircraft can slip between trajectories if their path changes at the right moment. A curtain works best when layered with other systems because it narrows options rather than closing them entirely. In this case, the destruction of one drone proved that analog weapons still matter, yet it also showed that surviving units can push forward if they accept losses. Defense in depth is only effective when every layer reinforces the next. This exchange also reveals a broader pattern in modern warfare, where advanced technology and decades-old equipment coexist on the same battlefield. A radar-guided missile battery and a manually aimed cannon can operate within minutes of each other, and each carries strengths the other lacks. Missiles extend reach and precision, while guns provide immediate response inside short distance. For military observers in the United States who study force structure, this mixture raises questions about balance. Investing only in high-end interceptors may leave gaps against cheap threats, yet relying solely on volume fire risks exhaustion under sustained attack. The answer likely lies in integration rather than replacement. As the smoke from the gun bursts faded, at least some of the incoming aircraft had been stopped, but not all were eliminated. The sky remained contested, and the defense had already used both digital systems and mechanical firepower in rapid sequence. The attack had thinned, yet it had not collapsed. Even as ground crews attempted to seal the airspace with shells and discipline, another element entered the engagement that few planners would consider ideal for anti-drone duty. At this stage of the engagement, the defense shifted from ground systems to a manned aircraft, because a Mi-8 helicopter reportedly moved in to pursue the remaining UAVs and attempted to stop them in open air. The Mi-8 is a transport platform, not a specialized interceptor, yet it carries a side-mounted machine gun that can deliver heavy fire at short range. In this case, the crew used that weapon in an improvised defensive role, and reports indicate that one additional drone was destroyed during the chase. The door gunner relied on visual tracking and sustained bursts, and at a range of a few hundred meters, even a small unmanned aircraft can be vulnerable to concentrated machine gun fire. The rate of fire from a multi-barrel system can exceed several thousand rounds per minute, which means the air in front of the helicopter can become lethal in seconds. This engagement reflects improvisation rather than doctrine, because transport helicopters are not designed as dedicated anti-drone platforms. The Mi-8 was built to move troops, equipment, and supplies, and although it can carry defensive armament, its primary role is not air policing against small, low-cost targets. Pursuing lightweight UAVs requires tight maneuvering and precise angles, yet a helicopter has size, weight, and mechanical limits that restrict aggressive movement. Pilots must consider rotor stress, altitude, and speed balance, while also maintaining awareness of ground-based fire zones. That combination creates tension between offensive action and survival. The destruction of one drone demonstrated that manned aircraft can neutralize slow unmanned threats under the right conditions, yet it also exposed a larger issue: cost imbalance and exposure risk. A helicopter represents a far more valuable asset than a disposable UAV, both in price and in trained personnel. Losing such an aircraft would carry greater strategic and symbolic weight than losing several drones. In economic terms, using a multi-million-dollar platform to intercept a far cheaper device may succeed tactically, but still raise questions about sustainability. For military planners who analyze exchange ratios, this imbalance is not theoretical. It shapes long-term force design decisions. The chase also introduced the danger of friendly fire, because as the helicopter followed the drones closer to base, it approached the defensive envelope of its own side. Air defense systems protect sensitive facilities by engaging any object that enters restricted space without proper coordination. In a tense moment, identification can become uncertain, especially if multiple radar tracks overlap. Reports suggest that the crew chose to disengage rather than risk entering the automatic fire zone surrounding the airfield. That decision reflects a basic principle of layered protection. Avoiding blue-on-blue incidents can be as important as destroying incoming threats. A single miscalculation could have led to catastrophic loss. This moment shows the limits of conventional aviation against modern unmanned tactics, because helicopters are not optimized for persistent counter-drone patrols. They consume fuel quickly, require maintenance after intensive maneuvering, and depend on human endurance inside the cockpit. Meanwhile, remote systems can operate without fatigue and without risk to onboard crew. That contrast matters when conflicts stretch over months and years. An aircraft crew cannot chase every small object that appears on radar, and defense networks must prioritize assets carefully. Even after the aerial pursuit ended, the situation remained unstable because at least 2 drones were still advancing toward their objective. The helicopter's intervention had reduced the number of attackers, yet it had not eliminated the threat entirely. This reveals another truth of layered security. Each response buys time but does not always deliver final resolution. When attackers accept losses and continue forward, defenders must prepare for the next line of contact. As the Mi-8 turned away to avoid entering its own fire envelope, the remaining unmanned aircraft pressed ahead toward the airfield perimeter. What followed was not a quiet glide into restricted space, but a sudden and chaotic test of how well-based defenses could react under compressed time and rising stress. When the final 2 UAVs crossed into the airfield perimeter, the battle shifted from interception to pure reaction, and that moment exposed how difficult close-range defense can be under stress. Reports indicate that both aircraft entered restricted airspace at low altitude and moderate speed, which left only seconds for personnel on the ground to respond. Infantry units and at least 1 armored vehicle reportedly opened fire, but coordination appeared fragmented. In situations like this, defenders must instantly decide which target poses the greater threat, and that split decision can slow response time. When multiple threats move in different directions, even trained crews can hesitate for a fraction of a second, and that pause can determine the outcome. Armored support vehicles, such as those equipped with autocannons, are designed to provide flexible firepower, yet they rely on turret rotation speed and clear target acquisition. A turret that requires several seconds to pivot toward a new bearing may struggle when an object approaches from an unexpected angle. In high-speed engagements, 8 seconds can represent hundreds of meters of travel, and by the time alignment is complete, the target may already be over critical infrastructure. This is not a failure of equipment alone. It is a challenge of timing and prioritization under pressure. Airfield defense demands constant readiness, but sudden multi-directional threats test even experienced crews. The first drone reportedly struck a Nebo-U radar system positioned at the base, and that target carries strategic weight. The Nebo-U is known as a long-range surveillance radar capable of monitoring airspace across hundreds of kilometers. Its large antenna array and electronic modules support early warning and air picture development. If reports of heavy damage are accurate, the impact could have disrupted local detection capacity, at least temporarily. When a radar antenna is compromised, the system cannot perform as designed, and repairs often require specialized components. Replacing or restoring such equipment is not immediate, and in wartime, supply chains can be strained. Moments later, the second UAV reportedly hit the helicopter parking area, where several Mi-8 aircraft were stationed. Helicopters parked close together create logistical convenience, but they also increase risk if a fire starts. An impact near fuel tanks can lead to rapid ignition, and aviation fuel burns intensely once vaporized. Secondary damage to nearby aircraft may occur through heat, debris, or pressure waves. While the full extent of destruction remains unclear, even partial loss of rotary wing assets can affect transport, logistics, and rapid response capability in the region. It is important to note that damage assessments remain partially unverified by independent sources. Open-source imagery and official statements do not always align, and in active conflict, information can be incomplete or delayed. Exact recovery timelines and operational degradation have not been fully confirmed. Some systems may be repairable within weeks, while others could require replacement or relocation. Analysts must treat early reports with caution, especially when evaluating long-term strategic impact. Regardless of final numbers, the event revealed something deeper than physical destruction. It showed how reaction speed and system integration matter as much as hardware quality. When threats arrive in quick succession and from unexpected directions, defenders must align sensors, shooters, and decision-makers without hesitation. Even a brief lapse in coordination can allow penetration. Modern air defense depends on seamless layers working together, and when one layer experiences delay, the burden shifts to the next. For observers who follow military developments closely, this incident serves as a reminder that protecting high-value assets requires constant adaptation. Radar systems and aircraft are symbols of capability, but they also demand protection from evolving threats that are smaller, cheaper, and harder to predict. The engagement near Eupatoria may have lasted only minutes, yet its implications reach further than the smoke rising above the runway. Beyond the explosions themselves, the broader implications reach far beyond one airfield. What happened near Eupatoria was not just a strike, because it showed Russia's defense can still shoot, yet it can still be forced into costly choices. First, a Pantsir missile took down a drone offshore, then the survivors changed their flight and pushed the timeline tighter, and that is where the weakness appeared. Next, the Zu-23-2 stopped another target with dense fire, but it needed huge volume to do it, and volume is not a long-term plan. Then a Mi-8 chased and killed one more, but it had to break off to avoid its own air defense zone, which says coordination is still a problem under stress. Finally, 2 drones reached the base, and the results were measured in high-value equipment, while the attackers spent far less. That cost gap is an advantage Russia cannot ignore. If you want more clear, fact-based breakdowns like this, subscribe to Military Force.